Minute table part 2. Got another one? Yes. We have the evil twins. Or you call them the evil cousins, whatever you like. Let's get the same angles up in there. Okay, now these are called the reciprocals. The reciprocal functions, the reciprocal trig functions, because they are the reciprocals of what you guys already know. You guys have been introduced to sine, cosine, and tangent. Now meet cosecant. Cosecant, he is the evil twin of sine. And then we have secant. He is the evil twin of cosine. What? Another co? Yeah, another co. See here, it's sine and cosine. Here, it's secant and cosecant. Oh, didn't see that coming down, did you? Okay, and then we have the reciprocal of tangent. That would be cotangent. That's cot. All right, and so now let's fill in this box really fast, this quick little mini table, and we're going to use all our values right here up in this mini table. What is the reciprocal of 1/2? Dose. Oh, that was simple. What is the reciprocal of this dude? It'd be 2 over rad 3, but we can't leave the radical in the denominator, right? We multiply the top and the bottom by rad 3. What would 2 times rad 3 be? 2 rad 3. And then what would rad 3 times rad 3 be? 3. All right, and then we have the reciprocal of sine of pi over 4. That's going to be 2 over rad 2. And when I get 2 over rad 2, again, I have to multiply top and bottom by rad 2. So what do we get? Ooh, that one's kind of weird. Oh, yeah, it simplifies just the rad 2. Man, you're fast. Oh, you fast. And multiply top by rad 2 and the bottom by rad 2. Magic happens, and the 2's cancel out because you multiply top by rad 2, you get 2 rad 2. You multiply bottom by rad 2, you get 2. The 2 cancel out with the 2, and you're left with rad 2. So secant of pi over 4 is going to be the same. Bam, bam, bam. And then we have cosecant of pi over 3. That's going to be the reciprocal of this dude, which we already did over here. Remember him? Yeah, we do the reciprocal of that dude. What is the reciprocal of that dude? It's 2 rad 3 over 3. And then we have the reciprocal of 1/2, which is just 2. And then we have cotangent, the last trigonometric function that we're going to be working with. He is the reciprocal of tangent. So the reciprocal of tangent, let's see. Let's think about tangent for a second. What is tangent? Tangent of theta is sine divided by cosine. Right? Y value divided by x value. Y value divided by x value. Y value divided by x value. That is what tangent is. It is sine divided by cosine. Opposite over adjacent. Okay, so if tangent was sine divided by cosine, what do you suppose cotangent would be? Yeah, you got it. Cosine divided by sine. So actually what ends up happening is when you go cosine divided by sine, you're going to get this. So that one's going to be rad 3. This one's the easiest one because rad 2 over 2 divided by rad 2 over 2. Or I'm sorry, the other way. This rad 2 over 2 divided by that rad 2 over 2. That'll equal 1. And then we have this guy right here, which happens to be this guy. Because if you go 1/2 divided by rad 3 over 2, that's the same as 1/2 divided by rad 3 over 2. So we're going to write rad 3 over 3. Okay. So I really want to teach you guys lots of ways you guys can figure out trigonometric values. All right, these guys, all of these numbers, these are trig values, and more specifically, they're trig values in the unit circle. And the reason why we use them is because we can get exact values of these really easily. Other angles do not make it that simple. Don't make it that pretty. These ones are the prettiest trigonometric values out there. So that's why we use them. Okay, these are trig values. So whenever you see something that says find the value of each trigonometric function, you're going to be using those values. Okay, unless you're not inside the unit circle. If you're not inside the unit circle, it might look a little different. So, can you guys figure this out? What is sine of 4 pi over 3? You get this, ask yourself 2 questions, and those are, what quadrant are we in? You know, because of this angle, what quadrant does this angle take us to? And then, what reference angle will you be referencing in the first quadrant. These are the ones that you really have to make sure you know, because if you know all these, then you know all the quadrants. So we are in quadrant 3, which tells us something. All right, and to tell you what it tells us, I want to ask you another question. Which two quadrants have negative sine values? Remember, we equated sine to the height function. So where do you have negative heights? Which two quadrants do we have negative heights? If you said the bottom two quadrants, you were right. Quadrant 3 and quadrant 4 have negative sine values. Hey, on the same note, sorry, rabbit trail here. Which two quadrants give you negative cosine values? That's right, the left side of the graph. Quadrants 2 and quadrants 3. Quadrant 2 and 3. Okay, what is the reference angle for this? Now that's actually pretty simple when you're dealing with radians, because you just have to look at the denominator. Our denominator is 3. So which reference angle will we be looking at? Pi over 3. So if we look at pi over 3, what is sine of pi over 3? It is 3 over 2, but then we have our negative sign. Why is it negative? Because we're in quadrant 3. So these questions right here, they kind of really help with the mini table. If you're using the mini table to find trigonometric values, you ask these two questions to yourself, and you can find the trig values that you're looking for.